Hello and namaste everyone. I'm Assistant Professor Sunil Rakhal from Institute of Engineering, Tribhuvan University, Nepal. Deliver a lecture on course titled Applied Mechanics, and today's topic is friction, that is chapter 5 and lecture 7. Let's delve into its learning objective. First of all, student will learn and understand the fundamental laws of friction. These objectives involves grasping the basic principles governing frictional force, including different laws of frictions. Learners should comprehend how these laws describe the relationship between the force of friction and the normal force acting on an object, differentiate between static and dynamic coefficient of friction. So static coefficient of friction refers to the friction force between two surfaces when they are stationary relative to each other, while dynamic coefficient of friction applies when the surfaces are in motion. Understanding these differences is crucial for predicting and analyzing the behavior of objects under different conditions. Calculate the angle of friction and its significance. So, the angle of friction, often denoted by the Greek letter theta, is the angle at which an object on an inclined plane is on the verge of sliding. Knowing how to calculate this angle is important in various engineering contexts, such as designing ramp, slopes, or determining the stability of a structure on inclined surface. And another objectives is analyze the real world engineering examples demonstrating the practical uses of friction. This objective involves examining practical applications of friction in engineering, such as design of brakes in vehicles, the operation of conveyor belts, or the stability of structure in earthquake prone areas. By studying these examples, learners can understand how friction influences the performance and safety of engineered systems. Students will learn and apply the how to apply the principles of frictions to solve engineering problem. Learners should be able to apply the principles of friction to analyze and solve engineering problems related to structures. This could include determining the forces acting on the different components of a structure, evaluating the stability of a structure under various loads, or designing mechanism to optimize frictional force for a specific purpose. And another objective focuses on developing the skills to calculate specific friction related parameters relevant to engineering structures, such as the tension and friction grip bolts. Learners should understand how to apply the appropriate formulas and principles to accurately determine these parameters in practical scenario. All right, let's dive into the exciting world of friction. Today we'll explore how friction impacts our life and the principle behind it. So, what is friction? Well, imagine you are trying to slide a heavy box across the floor. You will feel a force pushing back against your hand. That's friction. It is the force that resists the motion of one object sliding or trying to slide past another. When one body slides or tends to slide over another, resistance is always offered to its motion in the tangential directions. This tangential resistive force is termed as frictional force of friction force or force of friction. So there are two types of frictions. One is static friction and another is dynamic friction. The frictional force experienced by a body at rest. In fact, it is the frictional force acting on a body which tends to move. We are going to talk about static and dynamic friction. So, static friction happens when an object is at rest, like when you are trying to push a heavy sofa. The dynamic friction, on the other hand, kicks in the when an object is already in motion, like when you are riding a bike and applying the brake. So dynamic friction can be classified as sliding friction and rolling friction. So sliding friction occurs when the body slides on another body, and by other hand, rolling friction occurs when rolls over another body. One body rolls over another body. Think about all the ways we use friction in our everyday lives, from manufacturing industries to vehicles braking systems. Friction is everywhere. It helps us walk, drive, ride, and even climb rocks. Certainly, here are some examples of engineering applications where friction plays a crucial role. So, friction play crucial roles in braking systems in vehicles. Friction between brakes pad and rotors is essential for slowing down and stopping vehicles. Engineers design braking systems to optimize frictional forces, ensuring efficient braking performance while maintaining safety. In traction control systems, in vehicles utilize friction to prevent wheel slippage on slippery surface. By adjusting the distribution of torque and applying brakes selectively, these systems optimize traction to improve vehicle stability and control. In conveyor belt systems, conveyor belts rely on friction between the belt and rollers or pulleys to transport materials efficiently. Engineers design conveyor systems with specific frictional characteristics to ensure smooth and reliable operation in various industrial applications such as manufacturing and logistics. In clutches and transmission, friction clutches are commonly used in automotive transmission to engage and disengage power transfer between the engine and transmission. Engineers design clutches to provide the right balance of frictional engagement for smooth shifting and efficient power transmission. In threaded fastener, threaded fasteners such as screw, bolt, and nuts rely on friction between mating threads to maintain joint integrity and prevent loosening. So, engineers consider frictional characteristic when designing threaded connection to ensure proper clamping force and resistance to vibration, included induced vibration induced loosening. And in the rock climbing equipments such as carabiners and ropes utilizes friction to secure climbers and support their weight. Engineers design climbing gear with specific frictional properties to ensure reliable grip and minimize the risk of slippery or slipping or falling during ascent and descent. So these examples demonstrate the diverse range of engineering applications where friction is essential for functionality, safety, and performance optimization. But friction is not all sunshine and rainbow. It can cause wear and tear on machine parts, reduce efficiency, and even create annoying sounds in unmanaged system. However, without friction, we would be slipping and sliding all over the place. So friction causes undesirable effect like tear and wear of mechanical parts in machine, and hence overall efficiency of machine is reduced. Without friction, we cannot do things in our daily lives as we do. We can't walk, cannot drive a vehicle, cannot hold the pen. Friction cannot be avoided in machines. It should be noted that it could be reduced by application of lubricants. Here are some advantages of frictions. Friction helps the motion of vehicles by gripping. Vehicle braking systems is the application of frictions. Friction can convert mechanical energy into heat and light. Friction helps us for efficient torquing in many activities. Friction helps to transmit power from bent system and clutches. We can ride, walking, running without sleeping. And here are some disadvantages of frictions. Friction produce unnecessary sound at unmanaged system. Friction reduces the life of machine parts. It reduces the efficiency of work due to energy dissipation. Friction causes unnecessary wear and tear at the machinery part. Opposes the motion, so greater energy is required to overcome. Now let's talk about Coulomb's law of frictions. These laws helps us understand how friction works. For static frictions, the force always opposes the tendency of surfaces to slide. Friction force always acts such as to oppose the tendency of one surface to slide relative to the other. It acts tangential to the surface in contact. The magnitude of frictional force is equal to the force applied to move the body up to impending motion condition. The maximum force of friction is independent of the area of contact. Force of friction depends on the nature of surface in contact. The magnitude of limiting static frictions is proportional to the normal reaction between the two sliding surface. Hence, the limiting static friction, that is maximum static friction, is directly proportional to the normal reaction. Here we can see Fs max proportional to n. Fs max is equals to mu s into n. So mu s is equals to Fs max by normal reaction n. So mu s is coefficient of static friction. And here are the laws of dynamic or kinetic friction. Dynamics or kinetic means the body is in motion. So frictional force always acts in opposite direction to the direction of motion of body. For low relative velocities between sliding bodies, frictional force is independent to the relative speed with which the surfaces move each other. The ratio of kinetic friction to the normal reactions is always constant. So the ratio of kinetic friction means Fk to the normal reaction n. Fk by n is equals to mu k, that means constant. Mu k is called coefficient of kinetic frictions. Note that frictional force is equals to mu s into n, is applicable only at the point of impending motion. Impending motion means there is no motion, but just move condition. Impending motion means just start to move condition, but there is no motion. If the body does not move under the action of external forces, then the frictional force developed is less than the maximum value of static friction. Once motion has started, the frictional force is equal to kinetic friction, which is less than the maximum static friction. That means maximum static frictional force is greater than the kinetic frictions. That means friction force is in static condition. Friction force in static condition is greater than the friction force in kinetic conditions. We want to discuss here the limiting friction and impending motion. So we can see here in these figures, in figure first, the applied force P is greater than 0. That means we apply the force P in rightward direction, but very small, no motion but in equilibrium. That means if P is applied in rightward direction, then the friction force opposes this motion in opposite direction. That we can see in first figure, the friction force F acts in opposite direction to applied force P. If this applied force P is gradually increased to P1, the friction force F also increases. Hence, the maximum or limiting value of frictional force which acts on the body, it just starts to slide. It's called limiting static friction and is denoted by Fs max. Limiting friction means the maximum frictional force that acts on the surface at the condition the body just starts to slide, but there is no slide at all, just starts to slide. When the applied force becomes equals to maximum frictional force, the body just comes into motion. This stage of motion is called impending motion. At the impending motion condition, the friction force is maximum, and this maximum frictional force is called limiting static frictions. At the point of impending motions, the friction force is maximum frictional force, and when the applied force is greater than this maximum static friction force, the body moves or slides. The variation of frictional force with respect to external applied force. We can see here in this figure, in y-axis is the force, static friction force, and in the x-axis external applied force. The figure shows that the increase of frictional force is increase of applied force in the same ratio up to the point of impending motion. Beyond the point of impending motion, the frictional force drop to force of kinetic friction Fk, and it almost constant. Depending upon the value of frictional force developed between the contact surfaces, we come across three different conditions. One is when the applied force F is less than the maximum static frictional force, there is no motion. No motion occurs. And in the second case, if the frictional force is equals to the maximum static frictions, motion impedes, means just start to move conditions. And in case 3, if the applied force F is greater than the maximum static force Fs max, the body under motions, the body moves with kinetic static frictions Fk. We want to illustration of coefficient of static friction is greater than the coefficient of kinetic frictions. That means coefficient of static friction is greater, or friction force in static condition is greater than friction force in dynamic condition or kinetic conditions. The ratio of the frictional force to the normal reaction is called coefficient of friction. Examples: mu is equals to F by R. We know frictional force is maximum at the stage of impending motion. At the stage of impending motion, let us consider a body having weight W is experienced by a maximum frictional force Fs at the impending motion condition. We know mu s is equals to Fs by n in static condition. That means coefficient of static friction is the ratio of frictional force to the normal reaction. So in equilibrium, we can see here in this figure, in equilibrium, P force is acting rightward. So P, rightward direction positive, and this Fs is the friction force that is act in opposite direction to the applied force P. So this Fs is minus Fs is equal to 0. 0 means there is no movement, there is no motion, there is static conditions. So P is equals to mu s into n, because Fs is equals to mu s into n is equals to 0. Here mu s is equals to applied force P divided by n, means mu s is equals to P by n. And in other hand, when the motion starts, the maximum friction force falls to some value less than F max, called Fk. If coefficient of kinetic friction is equals to mu k, applying equilibrium condition for motion condition, that means this is the figure of motion condition. There is a movement having acceleration a and the mass of the body is m. Ma is the acceleration produced by this applied force P. So in motion condition, applying equilibrium, so P is in rightward direction, so P, and this is the kinetic static friction Fk is in opposite direction to applied force minus Fk, and is equals to Ma, means there is acceleration in rightward direction. So rightward direction taking positive is equals to Ma. P is equals to Fk is equals to mu k into n is equals to Ma. So mu k is equals to P minus Ma by n. So from equation I and II, From equation I, mu s is equals to P by N, and these equation I and II, by comparing this equation, acceleration is greater than 0. We know this acceleration A have some value, so acceleration is greater than 0. When the value of acceleration is greater than 0, so this quantity is less than this quantity. That means we conclude that the coefficient of static friction is greater than the kinetic friction, means this quantity is greater than the of this quantity, means this quantity is equals to mu s, means coefficient of static friction, and this quantity is equals to the coefficient of kinetic friction, and this kinetic coefficient friction is less than the this coefficient of static friction, means coefficient of static friction mu s is greater than the coefficient of kinetic frictions. I want to discuss some frictional terms. The term is normal reactions, angle of frictions, angle of repose, and what is normal reactions. The force exerted by a surface on an object in contact with it, which prevents the object from passing through the surface. An angle of friction means an angle made by resultant of normal reactions, means these are the angle made by resultant of the normal reactions, and limiting frictional force with normal reaction is known as angle of friction, that is denoted by phi. Phi is the angle between normal reaction and the resultant force. This resultant comes from normal reaction and the limiting frictional force. Angle made by resultant of normal reaction and limiting frictional force with normal reactions is known as angle of friction. So, from the geometry of triangle, this is the angle of friction phi, angle made by this resultant and normal reactions. From geometry of triangle, tan phi is equals to fs max divided by n, means in this triangle this is the angle of friction. So, this leftward force is friction force that is acting rightward, that means acting rightward in this triangular form, and this upward force or this side represents the normal reaction n. So, tan phi is equals to P by B, that means Fs max by n. So, from this equation Fs max is equals to mu s into n. So, tan phi is equals to Fs max by n, means Fs max by n is equals to mu s, that means Fs max by n is equals to 10 phi, that is equals to mu s. Thus, the tangent of the angle of static friction is equals to the coefficient of static friction. 10 phi means the tangent of angle of static friction is equal to the coefficient of static friction. Lastly, tangent of angle of static friction is equals to the coefficient of static frictions. And what is angle of repose? The angle of inclinations with horizontal for which the body on inclined surface is in the verge of motion without applications of any external force, and verge of motion means just starts to move. So this angle theta is called angle of repose. Angle of repose means inclination to the horizontal. So inclination of inclined plane to the horizontal, for which the body for which the body on the inclined surface is in the verge of motion without applications of any external force. There is no any external force, so this object, this body is in the verge of motion, and at this condition this theta is called angle of repose. So at equilibrium conditions, here we can see in this figure the normal reaction from inclined surface is in upward direction, that is denoted by n, and the weight of this body is acting vertically downward, that is mg. So this theta is equals to this theta. So this vertical direction weight mg is divided into two components. One is mg cos theta, that is acting downward from inclined surface, and the another component is mg sin theta, that is parallel to this inclined surface. One is perpendicular to the inclined surface, that is mg cos theta, and the perpendicular to the inclined surface, that is mg cos theta, and the parallel to the inclined surface, that is mg sin theta. These are the components of this mg which are acting vertically downwards. So this body is in the verge of motion in downward condition. So frictional force always acts on opposite direction to the motion, means verge of motion condition in downward direction. That's why this frictional force Fs is acting upward direction, which is shown by arrow in upward direction. So these are the free body diagram of these conditions. So for this body at equilibrium conditions, these static frictions is equals to the this force. That means at equilibrium the applied force is equals to the friction force. That means Fs is the static friction force, that is equals to the mg sin theta, or we can say in this direction take positive, and the force Fs is acting upward direction, that is positive, and this mg sin theta is acting in opposite direction, that is negative mg sin theta, and there is no motion, so is equals to 0. So from these we can say Fs is equals to mg sin theta, that is equation 1. And in another way, this direction is taken positive, so n is acting upward, that is positive n, and mg cos theta is acting downward, that means minus negative mg cos theta is equals to 0. That means there is no motion at all. So n is equals to mg cos theta, that is equation number 2. So from equation 1 and 2, tan theta is equals to fs by n, means divided by equation 2. Equation 1 is divided by equation 2. We derive this tan theta is equals to fs by n, and fs by the ratio of frictional force to the normal reaction is also called coefficient of static friction, mu s. That means tan theta is equals to mu s. Also we have tan phi is equals to mu s, that is derived already. Tan phi is equals to mu s. So finally we can conclude that tan theta is equals to tan phi. That means theta is equals to phi, means the angle of repose is equals to the angle of friction. Finally, angle of repose is equals to the angle of friction, and the angle of repose is the inclination with horizontals for which the body on the inclined surface is in the verge of motion without application of any external force. Verge of motion means just start to move conditions. At that conditions, the angle of repose is equals to angle of frictions. We want to discuss the condition of tipping and sliding of a block. So what is tipping and sliding of a block? Is the magnitude of applied force P increases, frictional force F also increases. When we increasing the applied force P, then the friction force that is in opposite direction also increases. So P increases, frictional force F also increases, and the normal reaction N moves towards the right end of the block. Means when we applied force P, then the friction force is also act in opposite direction, which is increasing when P is increasing, and the normal reaction shift according to the applied force. Normal reaction and moves towards the right end of the blocks, so that the couple formed by P, means this P and F, is balanced by the couple formed by weight and normal reaction. The weight is acting in downward direction W, and the normal reaction act in upward direction, that is N. So this P and F is one couple, and this W and N is another couple, and these couple are balanced. We know couple formed by P and F tends to overturn the block, means P and F tends to overturn the block. So let us consider H is the height of the applied force. So H is the height of the applied force from the base. The produced couple of P and F is, means P into H. So this P force into height H. This is the couple formed by P into H, which is also equals to the Fs into H. So this is same, P into H or Fs into H. So we can say Ph is equals to Fs, means mu s into n, and H into H is into H. So Ph is equals to mu s into n into H. So when the friction force F increases from 0 to Fs max, the point of application of normal reactions moves to point B. So the couple formed by W and N is, W is acting vertically downward, that means W is equals to W into A by 2, means A is the base of this body. W act in centroid of this body, means at point B the magnitude of couple is W into A by 2. W is acting downward, so W into this distance is A by 2, means couple formed by W and N is equals to W into A by 2, or we can say this N is equals to this N into A by 2, also we can say N into A by 2. So couple formed by W and N is equals to W into A by 2 or N into A by 2. This N into A by 2. These are anticlockwise couple. This N into A by 2 or W into A by 2. So if there is no tipping, tipping means no directly overturn, both couples are in balance, so the condition for no tipping is this above equation is equals, means mu s and h is equals to n into a by 2. That means mu s h is equals to a by 2, and finally h is equals to a upon 2 mu s. A is the base of this object. Hence when h is less than or equals to a by 2 mu s, there is no tipping of this object. So h is the distance from the base to the point of application of applied force. That means height of the objects, or if we applied this force from middle, then h is the distance from the base to this middle. So if the normal reaction N reaches point B, if the normal reaction N reaches point B, this is point B, before frictional force reaches maximum, this friction force is less than Fs max, means if the normal reaction reaches point B, or if the normal reaction N reaches at the end point means B point, before frictional force reaches F max, so the block will tip or overturn about B before it starts sliding, when which is called tipping of the block. Tipping means this P force suddenly overturn this block in this direction. Overturn, tipping means overturn about some point. So here overturn about B before it starts sliding. This object starts sliding means the applied force and normal reaction balances each other, so the body slides. But here normal reaction and reaches point B before frictional force reaches F max, the block will tip or overturn. So if here this point B and the sudden force F is applied at this tip, this applied sudden force cause overturn at point B, because there is no any chance for the normal reaction to counteract this force, means there is formation of unbalanced couple by this P. This P overturn this block about point B. This normal reaction N shift at point B, and this P force suddenly act at this point, and overturn this block. This overturn means tipping of block. Normal reaction N reaches the point B before frictional force reaches F max. The block will overturn about B before it starts sliding, which is called tipping of block. When the applied force P is increasing in such a way, this applied force P is increasing in such a way that the friction force F reaches Fs max before normal reaction reaches at the end point B. So the block starts sliding. So means this P force and Fs max and this W and N is the balance couple, and the body starts to slide. There is no overturn. When the normal reaction reaches at point B, the block starts to slide along the surface of contact, which is known as sliding of a body. Means when the applied force P is increasing in such a way that the frictional force F reaches to Fs max before normal reaction reaches at the end point B, the block starts to slide along the surface of contact, which is known as sliding of a body. There is no sudden force. The P is slightly increasing and friction force is also increases to Fs before normal reaction reaches at the end point. The body will slides. The body will slides means these normal reactions acting at middle of this object and formation of balance couple, then the body starts to slide. This condition is known as sliding of a body. Illustration of condition of no motion, no friction, impending motion and motion. There is four condition of no friction, no motion, impending motion and motion. So I want to explain of these four conditions. The condition of no friction: if the force is applied normal to the surface, then the object exert only normal reaction from that surface and there is no motion produced from that applied forces, since no frictional force occurs at the surface. There is no friction condition. And another condition is condition of no motion: if the applied force is not greater than the produced friction force. That means this is the friction force and this P is applied force. This applied force P is not greater than this friction force, then the object is in rest condition. And if applied force is equals to this frictional force, then the object tends to move but no motion, but not in motion. Means the applied force is equals to or less than frictional force, there is no motion. That condition is condition of no motion. And another condition is condition of impending motion. Means the applied force is such that the body is about to slide. It means at the stage of impending motion. Means impending motion means when the applied force P is equals to the maximum static friction, the body just starts to slide or starts to move. At this motion is called impending motion, and this condition is condition of impending motion when the applied force is equals to the maximum frictional force. And the another is condition of motion. Means if the applied force P is greater than the maximum frictional force, after that stress the force creates motion of object. The in A is the acceleration and m is the mass, and this applied force P is greater than the static frictional force F max. Means frictional force after that stress the force creates motion of object. The friction force Fk is equals to mu k into n. Mu k is the coefficient of kinetic frictions. and this coefficient of kinetic friction mu k is less than the coefficient of static friction mu s. There is motion condition. So four condition: no motion, no friction, no motion, impending motion, and motion. There are four conditions that is arises by applied force and the friction force. And the another subtopic is high tension friction grip bolt. It is a structural bolt having high strength which have been tightened such as to induce tension in the shank of bolt structure. Because of the high frictional resistance, the interface between the steel member cannot move. So the effectiveness of high tension friction grip bolts relies on the principle of friction grip. When properly tightened, the friction between the bolt and the connected members resist external forces such as tension, compression, or shear. The clamping force generated by the friction grip ensures that the structural connection remains stable and can withstand various loads and environment conditions. A high tension friction grip bolt, also known as high strength friction grip bolts, is a type of bolt used in structural engineering applications to create a strong and reliable connection between structural member. And design and composition of these high tension friction grip bolts are typically made of high strength steel and undergoes precise manufacturing processes to meet specific mechanical properties and performance requirements. They consist of a threaded shank and a smooth cylindrical portion known as grip length. The grip length is crucial for providing the required clamping force between connected members. During installation, high tension friction grip bolts are tightened to a specified preload or tension using calibrated torque wrench or hydraulic tension device. The applied preload generates frictional force at the interface between the bolt and the connected members. These frictional forces create clamping pressure, ensuring that the connected members remains in intimate contact. High tension friction bolts offer several advantages over traditional bolted connections, including higher strength to weight ratio, improved fatigue resistance, and a reduced risks of loosening or failure due to vibration. They are particularly suitable for applications where reliable and durable connections are essential, such as bridge building, industrial structure, and offshore platform. The main principle or effectiveness of high tension friction grip bolts relies on the principle of friction grip. When properly tightened, the friction between the bolt and the connected members resist external forces such as tension, compression, or shear. The clamping force generated by the friction grip ensures that the structural connection remains stable and can withstand various loads and environmental conditions. And overall, high tension friction grip bolts provide a reliable and cost effective solution for creating strong and desirable connection in structural engineering applications, contributing to the safety, efficiency, and longevity of various infrastructure project. And here are the calculation involving friction. And the question is, block A, that is block A of weight 100 Newton rest on an inclined plane, and another weight W which is W is attached to the first weight A through a string as shown in figure. If the coefficient of friction between block and a plane, means block A and plane, is 0.3, determine the maximum value of W. The maximum value of W so that equilibrium can exist, means if this weight is increased, the block A shift rightward, means maximum value of W so that equilibrium can exist, means no movement, there is existence of static conditions. So given weight of block A is equals to WA, that is equals to 100 Newton, that is given by the questions, and the coefficient of friction mu s is equals to 0.3. At first draw the free body diagram of these given systems. Here the block tends to move upward because the maximum value of W, means motion creates by weight W block, means the free body diagram, this free body diagram of W block, the weight W is acting vertically downward from CG, and this weight W creates a tension in this string in upward direction. The tension is always away from body, that means for block W the tension is acting upward direction. So this is the free body diagram of W block, and the free body diagram of block A, means this A block tends to move upward direction when W is maximum, means tension is acting in this string in this direction, means away from body A. So the tension T is in upward direction. In the normal reaction from this inclined surface is acting upward direction R. So R is normal reaction from the inclined surface to the body, and W weight of A is acting vertically downwards. So this W is divided into two components. One is mg cos theta and another is mg sin theta. In the block A tends to move upward direction when W is maximum, means the friction force act in opposite direction to the movement, means opposite direction means inclined leftward direction. So FF is in inclined leftward direction, which is opposite to the movements. Now applying the condition of equilibrium perpendicular to the inclined plane, means this is the inclined plane and we choose the perpendicular to the inclined plane, means this direction take vertical direction. So assume this direction is vertical direction and upward direction is positive, means this is upward direction is assumed to positive, and summation Fy is equal to 0, means there is no movement, there is a condition of static equilibrium, but tends to move when W is increasing. So in summation Fy is equals to 0, means in first free body diagram of block A, we can see here free body diagram of block A, and applying equilibrium equation in this block A. So R is acting upward direction, means R is positive, and in mg cos theta, mg cos theta is acting downward direction, so negative minus mg cos theta is equals to 0. 0 means there is no movement, there is no acceleration, so summation fx or summation fy is equals to 0. This is the condition of equilibrium. So R is equals to mg, means the weight of the block A is 100 Newton, that is given by equation. So mg is equals to 100 and cos theta is equals to 30 degree. So from here we calculate the reaction, normal reaction R, that is equals to 86.60 Newton. R is the 86.60 Newton. And also applying condition of equilibrium parallel to the inclined surface, means this is the inclined surface, this is y direction, and this is x axis, y axis and x axis, means rightward upward direction is taken positive, means fx is equals to 0, rightward upward direction is positive. So means t is acting rightward, that is positive, and this mg sin theta is acting leftward, that is negative, and the friction force ff is acting leftward, which is taken as negative, is equals to 0 because there is no acceleration produced. So T minus mg means the weight of block A is equals to 100, and sin theta is equals to 30 degree, 100 sin 30 minus ff is equals to mu into n means normal reaction, which is represented by this r. So ff is equals to mu into r is equals to 0. So this mu is equals to 0.3, which is given by equation, and r is the normal reaction, that is equals to 8.60, which is already calculated above, is equals to 0. From here we calculate the tension T that is produced in this string is equals to 75.98 Newton, and from this tension T, applying equilibrium condition for the block W, means there is no acceleration, use equilibrium vertically, means summation of Fy is equals to 0. 0 means there is no acceleration. We want to calculate the maximum value of W. So means for free body of W, W is acting downward and T is acting upward. Means tension is always acting away from the body considered. So T is away from the body. T is upward direction, so take positive, and this W is equals to W is in vertically downward direction, so minus W is equals to 0. There is no acceleration, so W is equals to 75.98 Newton, that is equals to the tension produced in the string. Is this is the maximum value of W, so that equilibrium can exist. The maximum value of W is 75.98 Newton. When this weight of block is greater than 75.98, the block moves downward, means block A shift left upward direction. So the maximum value of W, so that equilibrium can exist, is 75.98 Newton. And from this concept we can solve other practical examples of friction. And finally we conclude our lecture today. Remember that friction is not just a force, it's a vital aspect of the intricate machinery that drives our world forward. So embrace its complexity, master its principle, and let friction pave the way for innovative engineering solutions. And finally, these are the references, and thank you.